Chapter 3.3 Notes, Properties of Functions, page 6. This will go fairly quick. We do have a correction to make on example 11, though it's mislabeled, so we're going to get there. Example 10, identify the local or relative and global or absolute extrema. Okay, so we do have a local maximum right here. And we're not even going to worry about identifying the values. It's larger than everything around it. It's that top of a hill that makes it a local maximum. We've got a local minimum right here. Smaller than everything around it. We have got an absolute minimum. Absolute. It is smaller than every other value, every other function value. Ew, I think my pencil's dying here. And then we've got an absolute maximum here. That is the largest function value on the interval. This endpoint right here that's not labeled could also be considered a relative maximum or a local. Because it is larger than any function value close to it. So 11, and here's where I'm going to disagree. This we're going to call a relative maximum. It is not the largest value, but it is larger than anything in the function close to it. Right here, we've got an absolute and relative minimum. So up above on 10, we could also say this is a relative minimum. It is smaller than everything around it. And 11, this is the very lowest value on that interval. We don't have an absolute maximum because that endpoint here at the 4, 4 that would be our maximum is not included in the interval. And keep in mind, if I try to come up with a value here that would be the maximum, I can pick a number less than 4, but really, really close. And I could still, I could average that number with 4 and still come up with something closer. So if that endpoint is open, we cannot call it a maximum or a minimum. If it is closed, then it's going to be a relative max or min based on what we have close to it.